Hello friends, welcome to Science Team. Till now we have seen that how different physicists and philosophers have described time in three ways. That is, time has been described as absolute. Some said that it is an illusion. And according to some, it is a byproduct of memory. Now we will discuss a few more theories on time. So let's start with the way Professor Stephen Hawking has described in his famous book, A Brief History of Time. So, from A Brief History of Time. Professor Stephen Hawking. He's very famous for his theory on black hole and Hawking's radiation theory. In his book, A Brief History of Time, Stephen Hawking talks about the arrow of time. According to Stephen Hawking, events happen in our world in a definite direction and not in the other direction or the opposite direction. So based on that, he has defined three arrows of time. So, the first is thermodynamics. The second is psychological. And the third is the cosmological. According to Stephen Hawking, time has some sort of direction which we call the arrow of time, and there are basically three arrows of time: the thermodynamic, the psychological, and the cosmological. So let's discuss one by one. So the first is the thermodynamics. The thermodynamic arrow. In our world, the events happen in a certain order or a sequence, but not in the opposite direction. So let's take an example. Just there is a glass and it is raised by some height, and we allow it to fall from a height. When this glass falls on the ground, it shatters into pieces, and we are filming this event with a camera. So when you play the video in the forward direction, you will find that the glass is falling and then it is shattered into pieces. But when you play this in opposite direction, you will find that all the pieces of glass are coming closer and then it is rising upward. So in our real world, no such things happens. The falling of this glass and breaking it into pieces is allowed. It can happen spontaneously, but the opposite thing cannot happen in our world by its own. The famous illusionist Franz Harari used to demonstrate a magic in which he used someone from the audience just put a sign on a pot, and he throws the pot allowed to fall it from a height, and he shatters into pieces, and after that the pieces come closer. When the magic start, the pieces come closer, and the pot is again recreated. So it's just an illusion, which was presented by Franz Harari, but no such thing happens in real world. The illusion which he created can be explained with the known laws of science, so it can be explained. But what you see in the video in the reverse direction, it does not happen in our real world. So in the real world, the events happen in a certain direction, and in certain direction the event does not happen. Or you can say that time prefers that direction in which usually the events are happening. We will come to that after we will discuss the concept of entropy. To understand the thermodynamic direction, we need to understand the concept of entropy. So what is entropy? It is the degree of order of randomness in a system. We will be discussing in brief. We will not go into details. To understand the concept of entropy, just imagine a library, and a group of students visit that library. The library is in ordered state, that is, all the books of the different sections are in their specific sections. Now the group of students visit that library, and they are just randomly taking the book from any subject, and they are just putting it anywhere. The next day when the librarian comes, he finds that all the books are just messed up. The books of history are in physics section, and the books of physics are in mathematics section. So just they have jumbled in the worst possible way. The next day when the librarian, after he observes that the library has been completely jumbled, a group of students from a different school visit that library, and a strange thing happens. No student is interested in arranging that library. They are just taking the books from different sections, just putting it anywhere. They are not even concerned about arranging the library. But when the next day, the second day, the librarian sees the strange thing happens, he finds that by chance every student who has taken any book from any section has put the book in the right section. It's by chance. No one is willing to put that book in the right shelf, but every student took the book from any section, and they're just keeping it anywhere. But by chance the library is now in completely ordered state. So in the real world this cannot happen. We know that there are many ways in which library can be in a disordered state, but there is only very few ways in which library can be in a ordered state. So there are more ways of arranging that library in disordered state compared to in ordered state. So the probability of finding that library in an ordered state is very less compared to be in disordered state, and this results in the common sense result that a library must be in disordered state after the group of two schools have already visited that library. Now take another system in which there is a bottle of scent in which you have some volatile perfume. Now we just open the lid of this bottle and the fragrance come out of this bottle and it fills the room in which it was present. If you closely observe it, you will find that some of the molecules are coming of the fragrance is coming out of the bottle and some air molecules are entering that bottle. So it's a two-way process. Now if one molecule of the scent came out, it can again return back. Not only the air can return inside, the molecules of the scent can go out and they can also re-enter the bottle. So imagine a world in which the molecules of the scent are disordered in the room now or spread in the room. Now can it happen that all the molecules which are present of the scent which is present in the room by chance can re-enter the bottle? There may be a chance, but there are very few chances in which they can re-enter. So we can say that there is very few probability that these molecules can re-enter. Some of them can enter the bottle again, but not all of them can simultaneously enter the bottle, because the number of ways in which these molecules can be spread out of the bottle is very large compared to that it can be present inside the bottle. So the degree of order of randomness is increasing when the molecules are outside. It can be in more disordered state. So we can say that the arrow of time is the thermodynamic arrow of time is directed in such a direction in which the entropy of the system or the randomness of the system is increasing by its own. We can decrease the randomness by some external factors, but spontaneously it should always increase, and the direction or the arrow of time is that direction in which the entropy of the system or the entropy of the universe is going to increase. So this is called the thermodynamic arrow of time. Have you ever thought how a digital watch or a computer or any digital or electronic device measures time? Even if you switch off the computer, if you again put it on, you will find that it is showing the right time. So there is a small battery which is keeping track of the time. So what is inside a computer or a electronic watch which measures the elapsing of time? Every computer and electronic device which measures time, there is a microprocessor or a microcontroller inside that. Inside the microcontroller or the microprocessor circuit, there is a small device which is called crystal oscillator. So what is a crystal oscillator? A crystal oscillator is a device in which there are two plates in between them some material which has some properties which we call piezoelectricity is there, and if we apply some small voltage, if we give some small constant voltage, due to the piezoelectric effect, the crystal vibrates, and it's like a cyclic process happening inside the crystal oscillator. So it is vibrating and it has some frequency, and by measuring that frequency we can measure the elapsing of time. Generally in computers, the voltage inside the circuit varies in the form of square waves. Like this is the time axis, so the voltage will vary like that, like this. It will be a square wave. That is, and it has some frequency. Its frequency is very high, probably in megahertz. So in this way the watches or the computers are measuring time. But what about the human brain? How a human brain feels that the time is elapsing? How a human brain feels the flow of time? So till now the modern science has no explanation or no satisfactory explanation for the fact that how a human brain generates the feeling of time. But as Stephen Hawking said, we cannot now with the present technologies can say how a human mind generates the feeling of time or measures time, but we can give some estimations about how a human brain could work. So according to Stephen Hawking, inside the brain there are neurons or the nerve cells in which there are many biological processes happening, and all the biological processes can be explained on the basis of some chemistry or chemical changes. So every chemical change can be explained with the known laws of thermodynamics. So all the activities inside the brain which are happening in the neurons can be explained on the basis of thermodynamic variables. So we can say that this psychological arrow of time must be in the direction of the thermodynamic arrow. So all the activities which are happening inside our brain, the neural activities result into the evolution of time. That is how our brain generates the feeling of time, or we measure time. So in our world we find that the things are happening in a certain way or order. Like for example, the falling of glass. Any object, if it is allowed to fall, will spontaneously go down. It will not go up. In this way the human brain has evolved. So the human brain has evolved in the long process of evolution and adaptation. It has developed the arrow of time, or it has developed the psychology in which the psychological arrow of time always points always points in the direction of the thermodynamic arrow. The human brain has taught itself to feel the direction of time, psychological direction of time, in parallel to the direction in which all the processes happening in our world. The psychology of the human brain has developed from observing the processes happening inside our real world. So the human brain has evolved. The human brain has evolved in such a way such that the psychological arrow of time always points in a direction parallel to the thermodynamic arrow of time. So overall we can say that the psychological arrow of time and the thermodynamic arrow of time are basically the same thing. So we can say that the psychological arrow of time and the thermodynamic arrow of time are directed in the same direction. So this is called the psychological arrow of time. So let's come to the cosmological arrow of time. Edwin Hubble, while observing the distant galaxies, found that the galaxies which are near to us appear to be blue in color or blue shifted, and the galaxies which are far are red shifted. He found that these galaxies which are moving away from us, the galaxies which are moving away from us are obviously should be far from us. So the distant galaxies appear to be red, and the galaxies which are moving towards us, towards the Milky Way galaxy or the solar system, appear to be blue shifted. So he compared the situation with the Dopplers effect, in which a moving source like a vehicle which is moving towards an observer and having some source of sound. It has some source of sound. So now we know that according to the Doppler's principle or the Doppler's effect, if a source is moving towards an observer, the frequency of the source, nu of the source, and the frequency observed by the observer, they are not same. The frequency of a source moving towards an observer appears to be higher. So nu O must be higher than nu S, and if this is going, if it's coming towards it, and if it's going away from the observer, the frequency of the observer appears to be lower. Frequency or the pitch of the sound appears to be lower than the source. So he compared the situation with the Doppler's effect happening in the case of a train or a vehicle sound, whistle. So he compared the case with the horn of a vehicle or a train. So if a galaxy is coming towards us, then the light which it is emitting and reaching towards us, light is a wave, so its frequency must appear to be higher, and the galaxy which is moving away from us, its frequency should appear to be lower. We know that the frequency of the light varies like this. The frequency decreases as we go from red to violet. This is the increasing direction of frequency, and the wavelength lambda increases in this direction. This is the direction of the increasing direction of wavelength from violet, indigo, blue, green, yellow, orange and red. So the frequency of blue light is higher than that of red. So a galaxy moving towards us should appear to be blue shifted, and a galaxy which is going away from us should appear to be red shifted. So this way Dopplers thought that the galaxies must be moving away from us, should be red shifted. Now he also observed that if we consider a balloon or a bubble, we are blowing air inside it, so we are inflating the balloon or the bubble. Then now consider 3 points on this bubble, A, B and C. So you can find a relation between the rate of receding or how, with what speed these points are separating as we are inflating the balloon with, or the bubble with, air. So you will find that 2 points which are far, AC is greater than here AB. You will find that the points A and C, the radius of this balloon is increasing in a symmetrical manner, or you can say that the balloon, we are assuming that the balloon is expanding in a symmetrical manner. So the radius is same everywhere. Now as the balloon is inflated, you will find that the points A and C which are distant, the speed of separation between the points A and C will be higher than the speed of between the points A and B. So we can clearly observe that 2 points on a balloon which are closer and 2 points which are far, the speed with which it is separating from each other is dependent on the separation between the points, and the same kind of thing he observed for the galaxies. So he concluded that the galaxies must reside on a expanding balloon, or we can say that our universe must look like a expanding balloon on which all the stars and galaxies are there. So we are living in a universe in which all the celestial bodies, all the galaxies, stars and every stuff inside the universe lies on the surface of a bubble, and this is what we call our universe, and all the galaxies are there. So one of our Milky Way is also here. So Hubble thought that if this bubble is expanding, if we go backward in time, its radius must decrease, and at some moment of time, billions of years back, all the stuff in the universe which is on the surface of which is on this spherical surface must come to a single point, which must be infinitely dense. This infinitely dense point from which the universe must start. Due to certain unknown reason, this point exploded. This explosion is called Big Bang. And after the Big Bang, all the matter scattered in the space and time, and the universe was created from that. So this is called the Big Bang theory, that the universe has started from a single infinitesimally dense point. The present laws of physics cannot explain the properties of that infinitely dense point. We only know the universe after it has been created. We do not know how the laws of physics were there at the beginning of the universe or at the Big Bang. There can be different laws of physics at the start of the universe. Now come to the cosmological arrow of time. What is cosmological arrow of time? The direction in which the direction or the arrow of time in which the universe appears to be expanding is called the cosmological arrow of time. So there are basically three curves explained by Friedman, in which the universe this is the radius of the universe, and this you can consider as time. The radius of universe is increasing after the Big Bang, and the other is the radius will become to a constant. It will become constant, and the other is that the universe has expanded, but after some time it will again reduce. It's like you are throwing a stone and it is going upward and then it is returning. So the same kind of behavior can be possible for the universe. The point with the infinitely dense point which exploded into the due to the Big Bang, and after the explosion, all the matter is expanding in the universe, and in some moment of time there is a possibility that all the matter can again return back due to the force of gravity, and in some moment of time the radius will start decreasing, and again the universe may collapse again to a single point. So this is the third graph. So this is our Big Bang. And the moment when all the matter will again come to a single point is called Big Crunch. So there can be a possibility of a Big Crunch. So we can only the different theories say that universe can be expanding, or we live in a universe in which the radius has come to a radius has become constant, or we are living in a universe in which there is a possibility of a Big Crunch. Whether we are, if Big Crunch is possible, so are we in this expanding phase or contraction phase? So Stephen Hawking said that the cosmological arrow of time is the arrow in which the universe appears to be expanding. In this phase of expansion, so in this expanding phase, the laws of physics are obeying the laws of thermodynamics. That is, in the other way we can say that the thermodynamic arrow of time is basically parallel to the cosmological arrow of time. So, but it will not be the same when this contraction phase will start from here to here. In that case, when the universe will start to contract, the laws of physics will behave in a different manner. and it will not be same as the present laws of thermodynamics. So Stephen Hawking explains this in Stephen Hawking explains this in this way. For example, consider a box in which you have some balls. There are white balls and there are some white balls and there are some black balls. It is filled with such balls. There are many black balls, and consider that there are a few white balls also. And if you just randomly take a ball from it, then the probability of getting a white ball will always be lesser than the probability of getting a black ball, because the number of black balls, the probability is given by the number of, for example, in this case, the number in the event and divided by the number in the sample space. That is, in this case, we have 2 white balls divided by, we have 1, 2, 3, 4, 5, 6, 7. The number of white balls is 2 and the number of black balls is 4, 5, 6, 7 is 7. So we have a total of 9 balls. So the probability of getting a white ball must be 2 upon 9, and the probability of getting a black ball should be 7 upon 9. Hawking explains this in a way that if we will be in a contraction phase of the universe and we randomly take out a ball from the box, then the chances of getting a white ball will be much higher than the chances of getting a black ball. So the laws of nature will behave in a different manner if the universe will start to contract. So we can say that the thermodynamic arrow is just following the cosmological arrow of time. So you can say that the cosmological arrow is the ultimate arrow or something like that. So this way Hawking has explained in his book the different arrows of time. In the next lecture we will be discussing about a few more theories about time. Till then, have a nice day. Please like, share and subscribe to our channel.